Okay guys, so let's see our next heap question. It's task scheduler. So we read the problem statement first. You are given an array CPU task, each labeled with a letter from A to Z and a number n. Each CPU interval can be idle and allow the completion of one task. Task can be completed in any order, but there is a constraint that there has to be a gap of at least n intervals between two tasks of the same level. Okay, so these are the test cases. So let me explain this test case. A, B, B, B. Okay, so it's A, B, 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 and S2. So basically the question says that we have to complete all these tasks. Okay, so we will return the minimum total time interval in which these tasks can be completed. If we complete A first, so A is done. So now since the time interval is 2, so the A will be done after these two intervals. So next A will be done here and the next A will be done here. Okay, so in this remaining time, so we can do B. Okay, so if we do B here, and the time interval for B is also 2, so 1 and 2, so B will be done here, 1 and 2, so B will be done here. So this will be our, if we see that this is our total time chart, total processing chart. So 1, 2, 3, 4, 5, 6, 7, 8. So its answer is 8. Let's see what if it's correct or not. So it's correct, 8. Okay, let's see new test case ACABDB. ACABDB. Okay, so ACABDB is n equal to 1. Okay, so see here, if we do C first, okay, then the waiting time is 1. Then we do A first, then the waiting time, then we do B, then we do D. Okay, and in the remaining time, if we do B here and we do A here, okay, so it will 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It comes with 6. But what if we can minimize this? Can we minimize this? Yes, you can. Okay, so if we start doing A first, then A. Okay, now our A is completed. Okay, now we will do B. Okay, now we'll do B, and the remaining is C, we can do here, and the remaining is D, we can do here or here. Okay, now if we count, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It is also 7. So it is not minimized yet. So let's see another. If we do A, then if we do A, okay, let's see further. A, C, and then A. Sorry. If we do A, then B, then A, then B, then C, then D. So we can see 1, 2, 3, 4, 5, 6. Its total time interval is 6. So it is minimized. So it is our correct answer. Okay. So how we achieved this? So there are some few observations which we have to consider. Like here, if we see this, in this, if we do C first, then B, then A, then B, then D, then A, this one. So here the frequency of the C is very less. Since the frequency of C is 1 and A is 2. Okay. So since C is 1, so if we complete the least frequency first, okay, then the higher frequency elements will be occupying the more time. Okay, because they need interval. Okay. So if we see in this, we completed A. Okay. Then B, and then after C. So since these two are having the frequency of 2 each, and these two are having 1 each. Okay, so we have a common observation that we have to place maximum frequency tasks first. Okay, and then after fill other. Okay, this is our observation. So how we will achieve this? Since you can see that for the frequency, what we have to do, we have to make a frequency map. Okay, frequency map. So this is our first step. First step is done. So now the second step is we have to take order of the frequencies. Okay, which element has more frequency, which has less frequency, and take out the more frequency element and put it in our the place it. Okay, place it at required position and all. So we have to use maximum heap. This is a kind of observation how we will. This is a pattern. Okay, this is a pattern. Like if we have to count or take or anything related to maximum and minimum elements, and the elements are changing. Like if we take out the maximum element and the other maximum will not be easy to find, so we will use maximum heap. Okay, in the maximum heap, what will we do? We will actually make the maximum heap for the frequencies. Okay, if we take out the frequencies, so if we take the maximum frequency first, in the maximum heap the top element contains the maximum frequency. Okay, this is A, this is B, and this is C. A has most frequency, so we will take out A. Okay, we will take out A, then B, then C, and so on. Okay, we will see it further. Okay, till this is our main observation. Okay, so let's go further. Let's take out A, B, B, B. Okay, A, B, B, B. A, B, B, B. And N is 1. Okay. Let me write the steps. First is map, create map. Second is maximum heap. Store a pair. I will explain why we store a pair. Store a pair for what pair? The character and the value. Character and the frequency. Okay. We will store the pair, character and the frequency. Okay. Now we will run a while loop. We will run a while loop of condition until our heap is empty. Okay. We will run this condition, and inside we will also run a while, and inside we will take a temp vector of pair. Okay, that pair will store this pair. Okay, that temp vector will store this pair. Okay, I will dry run, so don't worry. Okay, this will store, and we will run inside while loop for our n. Okay, we will decrement n and count the number of intervals. Okay, we will decrement n and count the number of intervals until n is greater than 0. We will run this while loop. Okay, at last, if the n remains and there are no elements to place, so we will, in our count, we will add all the remaining n. What is remain? So it will be idle situation. Okay, so let's code first, then we will dry run. Okay. So first, what we created, an ordered map. So okay, what's our next? To create a max heap. Okay, so we will fill this. And I dot, we are first putting, this is char comma int. We are first putting the int part, and then we will put the character part in this priority queue. Okay, so I dot first. Okay, now what will we do? Now we will run while loop. Okay, we will run this while loop. We will make a temporary vector. We will store the elements here. Okay, we will not store elements here, we will store the pairs here, and Now we will define a variable cycle. The cycle means the how many n are left. We will store n plus 1 elements. Okay, in every cycle, in every loop, in every iteration, we will reduce cycle. Okay, if the cycle is not reduced at last, that I showed here. In every iteration, we will reduce n. If the cycle remain at last, we will add this in our final answer. Okay, so now we will run inside our loop. Is not. And we will run condition that if cycle is greater than 0. Until the cycle is greater than 0, we will run this loop. What we will do here, we will first take the top element. Here it will be auto pq.top, because it will be at form of pair, not in the form of int, so it will automatically take its own data type. Okay, it will be pq.top. Okay, but check if its frequency is greater than 0 and decrease its frequency. Okay, so if whenever we take the top element, so we also have to pop. Okay, and we will decrease our cycle, and the time plus what is time? Time is the final answer. Okay, we will return the final answer in the time. Okay, time is the minimum time that the question is asking, minimum number of CPU intervals. We will take it interval or time, whatever it takes. Okay, so if top dot first -1 greater than 0, why we use -1? We used -1 to prevent the overflow condition, sorry, to prevent the underflow condition. So that's why we use -1. We will, if the element is 0, so it will not be decremented. If it is 1, it will decrement to 0, or 2, it will decrement to 1. So that's why we already checked if -1 is greater than 0 or not. Okay, so after this we will decrease the frequency. Sorry, we will not decrease the frequency here. I have already decreased this, so we will store that element in the temporary vector. So temp dot push back, what we will store, top dot first -1. I hope you understood why we use -1 here. We have decreased the frequency of that element, and top dot second. Okay, done. So this is how our inner while loop completes. So now for the outer while loop, we will now return back elements to heap. Okay, we will return back to heap. These are the updated elements which are having decreased frequency, or what I will explain. I will dry run at the last, then you will get it. Okay, now if the cycle remains, means it is not 0 yet, then decrease its frequency and add it as idle time in answer. Okay, so while empty time plus equal to cycle. Okay, this is how the cycle, at last we will return time. Okay, let's see if this run or not. There is a compile error. Okay, we have not stored it in the form of a. We will here use some curly braces. This is, I think, the mistake. Okay, now we will compile. There is a runtime error. Integer overflow, where it is time plus equal to cycle. Okay, this is because we are using while loop and we are not agreeing, so we will use if condition here. Okay, it's run. Okay, so now we are having dry run this. So we will dry run it here. We are taking this example A, B. Okay, and N is 2. Okay, now we will see our code. First we create a map. Okay, map A having 3, B having 2. Okay, so this is clear. Now we are creating a maximum heap of priority, means priority queue. So it is like this: A and then B. We are storing pairs here. So A having 3 and B having 3. Okay, this is mistake. Okay, now what will we do? We are initializing a time which is 0. This is our final answer. So final answer. Now we will run the while loop until our heap is empty. We will run this loop. Okay, we are making a temporary vector. In this we will store the pair. Okay, this n, for this n we are using cycle equal to n plus 1, means cycle is 3. Okay, cycle is 3. Now we are running inside while loop while cycle is greater than 0. Cycle is greater than 0 because the cycle is actually the wait time. Okay, until the wait time is finished we have to run this. Okay, cycle is greater than 0. What will we do? We are taking the top element. The top element is this A3. This is our top element. We have to push. Okay, we have to push this element in the temp. Okay, this we are pushing. Sorry, we are pushing this element with the decreasing its frequency. So 3 is decreased to 2. Okay, our cycle now become 2. Okay, and our time will become 1. Okay, now what will we do? Our this heap will become B3 and A2. Okay, now we have to repeat this procedure same. So it will decrease to B2, cycle will decrease to 1, and time will increase to 2. Okay, now repeat this procedure for this. So A1, then B1. Okay, cycle will be 0, time is 3. We'll get a new cycle. Cycle is 3. Since the first iteration complete, now we'll get a new cycle 3. Our time is 3. Okay, and what is remaining? A1 and B1. Okay, we will put it here, A1 and B1. It will be our now heap. Cycle is 3. So since we will decrease its frequency. Cycle means 2 and it will become 4. Okay, so it will become now B1 and A1. A0 and B1. Now cycle will become 1 and it will become 4. It will become 5. Okay, and since our cycle remains 1 and time is 5 at last, and cycle remains, so we will add cycle to time. Okay, cycle to time. So time will become 5 plus 1 equal to 6. So 6 is the total interval time. Okay, 6 is the total interval time. So it is correct. It is correct. So this is our code. So we can submit this. So it's accepted. So let's wait for next question.